So I suppose a bit of background. I work for a corporate run by a bunch of Kiwis, so our good friends across the ditch. They put a fair bit of pressure on us to have quantitative data for the decisions we make. So I suppose EM electromagnetic induction is not new to any of us, but the actual use of the EM38 is probably alien to most people in this room. I doubt most people have even picked one up, let alone used one. And I think that's why the uptake of this device probably hasn't been so big, because it's all been contracted to do the survey for all the mapping. So I came across the EM38s last year. I've sort of had 3 seasons trying to make neutron probes work, and I'm jack of them, so if anyone wants a neutron probe reader, there's one for sale. And yeah, in a postgrad research assignment with UNE, I found the potential for the EM38 as a water measuring device. So a couple of take-home messages. Like a neutron probe, the EM38's a mobile soil monitoring tool. It's very accurate and has been used fairly extensively in the last decade by CSIRO and now DAF. So they swear by it and love it. So that's sort of why they're pushing it. Second point, this thing actually measures more than just a centimetre around the core of, like most probes do. There's a very small proxy for it, whereas this one's going over a metre, or if you want to make your own, you can actually extend it out to a lot bigger than that. The other thing, as I mentioned, people that want a quantitative figure to plug straight into your Excel spreadsheets for different management decisions, this thing's basically a tool that'll give you that. And the fourth, ease of life. I'm jack of fixing probes, pulling them in, putting them out, making them representative of the paddock, which I can never seem to do. So as a dryland farmer, how much information do we actually need? I suppose what we get asked, or what I get asked to come up with, is how much starting moisture and what the potential crop is, looking at climate and all that sort of stuff, and then using that to say how much N we want to put down, or whether it's even worth planting a crop. So last year we got 8 inches in one hit in about late March, April, and they put a lot of pressure on us to work out our nitrogen budgets, which ended up all getting flown on during the season. So there's a couple of, for dryland farmers, there's a couple of things there that I think a risk assessment, that we don't need exact information of where water levels are and stuff. We just need to know how much is in that profile as a starting moisture. And the last one, benchmarking. Everyone's getting right into benchmarking to self-assess how your performance of your crop is, where the constraints are, and how you go up against everyone else in your district. And if you try with probes, especially in cracking clays, it's nearly impossible to try and get an end reading that's actually works. And same with just your moisture probe, you just can't get in the ground. So yes, there is many technologies. Lots of people are doing different things. I've spoken to a few people, some advanced growers that are running cords 20 metres out in the paddock, 30 centimetres under the ground, to try and get that probe out there so no one hits it with tractors and whatnot. But yeah, you've still got all the same issues. You've got actually putting the probes in, you've always got something's going to hit it, spray rigs, headers, whatever they come across. So yeah, level of information. Consider, I suppose, how much can we actually influence the crop? Like, we're not irrigators, some of us probably are, but this thing can actually, we don't need to know where the deficit is or anything like that. The spread of our paddocks, the cost of actually owning probes to go right across all your different management units, or however much information you want. And that's why we went to neutron probes, because they're cheap posts, or like cores you can put in the ground and you can spread them everywhere. One device measures all. And yeah, then obviously operating systems for especially your wireless ones and all that sort of stuff. Capacitance probes, there's always problems getting those working. Different modules in them always seem to fall out of sequence over time. And then just logistical, where you put them, how you manage it with machinery operations and everything around the paddocks. So the EM38, you got a lot of options. So yeah, first one there's replicate sampling. I've had people ask or people comment what's happening on our paddock. So we putting all our mulch, like all our header trails back in the centre rows, and then the inter rows are all like so the outside the header trails, is that drying out a lot more than what's happening under the wheel tracks? So you could measure that sort of stuff. People that are putting deep P in, how much moisture you're losing from that deep ripping, you can just pretty much use that to go one side, leave a test strip and have another control strip on that side. It's that accurate, you can actually use that sort of scenario. And then, yeah, so you've got large zones. So this thing's, the standardised one's about 1 metre, so you're basically measuring 1 metre worth of soil, water in all that. And then you've got all the EM38 modelling and stuff that's coming out of CSIRO and DAF. So there, quick run over the issues again. Cracking clays, especially at harvest time, always a problem, and obviously machineries and all that sort of stuff. Basically, they're all the same. You've got to drill a hole, try and make them, put them in situ and try and make them blend back into the surrounding soils. So most of you know the EM38, most of you have seen them dragged around by quads and all that sort of stuff. They're also handheld, they run on a 9-volt little square battery. Pretty easy, pretty simple. So you can get around with them. They come out, you can buy a little computer handset for them as well to actually do data logging, all that sort of stuff. So at the moment I'm just currently just using it, taking a reading and plugging that straight into my Excel spreadsheets. But yeah, so there's that top picture there. You've got vertical use, and that goes down to 1.5 metres, and if you flip it on its side, that gives you 75 centimetres, which I basically go, top one's wheat and the bottom one's chickpeas. So if you've got a full profile of chickpeas, you just turn it on the side and you know you're not going to get all the way down the bottom. You're still getting a reading for how much you got in your chickpeas. So the CSIRO, this is straight from Neil Huth. He's basically used this slide to present this to a Precision Ag Expo, I think it was up UNE somewhere maybe. And this is basically showing what it is, the neutron probe versus the EM38 and just how accurate they are together. So basically you're getting the same stuff with half the hassle. This is sort of getting more into the technical side of it. So repeat measurements over time. So I've run around all my paddocks now straight after harvest. I've got my lowest level for especially a very dry finish. So basically I know exactly now what my chickpeas take out and what my wheat take out, and anything from that now I can just, when I go around with a full profile or part profile, I know how much moisture is actually in there and how much the next crop's going to remove. Andrew was going to talk a bit about this. There is a correction for temperature, especially when it's hot. They're saying there's a correction. Andrew thinks that for what we're actually using it for, we probably don't even need to worry about this. The actual minimums, the difference isn't that great. Number 3, the combined measurement. So the dipoles, you can get your different depth responses, and I think you can even buy shorter ones. So if you want a shorter, you want to know less than that, so you want to know a 30 centimetre or something like that. People, apparently this is not that hard to actually build, and they will custom make them if you want them to. Probably pretty expensive though, haven't looked into it. And then Pacific site calibration. So this is where comes into all the soil mapping, and I think it's soil map website. You can actually get all the where your calibrations and stuff are, and then the DAF and all that have been very helpful in helping us with different calculators and stuff from there. But yeah, that bottom point, think of it as a quantitative push probe. It's basically how I look at it. This is some of the regression lines they've been getting from the different the different uses on different paddocks. So basically the top one's your 150 centimetre and the bottom one's your horizontal. So that's just showing how close it is. And so most of this has been done off soil coring. So they've taken the soil core, then used the EM38 to actually measure and see how much is, or how close the curve is. And that's why these guys love it, especially for plot trials and that. They just put in each plot and they find what they need without going destructive or anything like that. So yeah, that's where I'm at. Lower crop limit, I've measured all that. So from now on, I'd basically wait for a full profile, or I could get my cores sent away and sampled to find out what the actual water holding capacity is. So yeah, when DAF and CSIRO do it, they basically do field calibration for each of their trial plots. They're putting their cores down, taking that, and then using the EM38 for the rest of the seasons, from what I can work out. Thanks to Howard for this one. So this is some of the chickpea trials being used this year. And this is just a plant population by water availability. And this is basically what you're getting. So this is how easy it is for them to just take a sample and find exactly what's happening underground. And for a lot of trials, there's probably a lot of information there that people can feed off. This is another one from Howard's. So this is density by row spacing, and it shows you it's got a pretty accurate, so we're talking 10 mils difference in some of those, and it's picking that up. So you can see the lines there with the different spacings and densities. So it is a very accurate tool. I'm pretty sure they said it's got a 99% accuracy, so there's 1% that it could be out if you don't have all the calibrations there. So for us, if we take out the temperature calibration, a few things like that, we're probably looking at maybe 5% off what its potential or how accurate it can be. So this is a sort of a look at our soils. So basically, our trigger for planting is 110 mils, and we want to know exactly what it is to plant. We don't want to practice growing a crop. We want to grow a crop that's going to make us money. If we don't get that 110 mils and we just won't plant, we'll fallow it out and make our money the following year. So this is a theoretical line, but basically this is what our scenario was last year. We had a wet surface down to about probably 30 or 40 centimetres, dried out, you put the push probe in, you got to about 40 centimetres, you're like, nah, no, I'm not going to plant this. But then you find a crack and it's full of water the whole way down. So basically where that line was, that's where we were hitting the hard spots, and we couldn't get the probe any further. But we eventually, some of our crops we got through to 4.6 tonne was the highest, down to 1.5. And if we had the EM38, we probably could have avoided some of those 1.5 tonne crops by just knowing how much water was down those cracks. The strength of this thing, as I mentioned before, 1% accuracy. Able to move between paddocks quickly. I literally just put in the back seat of the ute, drive around. Every time I jump out of the ute, I just put it on the ground, take my measurement, and off I go again. So you can go anywhere. Large sample volume, you're getting a metre worth of soil measurement rather than a centimetre, and you can pretty much go anywhere. Most farms have probably got EM surveys. Makes it a lot easier. So this is a couple of our paddocks. Pretty much, if we do a sample in the like a measurement in the green, so that's a consistent EM value across those paddocks, I can pretty much go anywhere in those paddocks, and my soil calibration, the calibration for my moisture measurement should be the same for right through there. So that's the advantage if you do have electromagnetic surveys across your paddocks. And I think it's enough information to make the main decisions. Weaknesses, soil variability. Everyone's got red ridges, avoid those. As I said, that's a pretty uniform paddock. Where we are is pretty uniform, but obviously other people are going to have some wildly varied paddocks and whatnot. So you're going to have to manage that when you use the device. Depth. Yeah, so you get two depths. If you're chasing sort of irrigation sort of style monitoring, this probably isn't the device for you. Mind you, in saying that, a lot of people have Jenny Foley and that have been doing the irrigation for working out amounts of infiltration for head and tail of a paddock and all that sort of stuff, and it's fairly accurate just for bulk water. The cost is a little prohibitive, $21,000. I think this will be a device that will probably be an agronomist tool rather than a farmer-based thing. I think if your agronomist can chip in for this and then just run around, it can basically spread the cost over a whole lot of growers. And then does not work well in sandy soils. This thing is basically just measuring electroconductivity. So you need that clay, you need the salts to give you a decent reading. Basically, a quick rundown of some of the things you can put this through. And this is what we go through every year, is trying to work out exactly how much water we've got in there, what the prediction is, and whether it's worth planting or not. So basically our summer crop for the last 3 years has been zip. And just a few pictures at the end, so that's a closer up version. So yeah, transmitter receiver, vertical and horizontal gives you the 2 depths. This is a bit more technical, so this is actually how it's measuring. I'm only new to some of this as well. Jenny Foley was filling me in. So on the horizontal, you're basically getting I suppose, most of your, I'm trying to remember how this works. You're getting most of your response from the 30 centimetre sort of area, and then it's a tail off either side of influence. So basically, where it's measuring from is taking a bulk reading from there, and then either side of that is just feeding into your final figure. And then that's sort of basically how it works with the eddy currents and all that sort of stuff. So yeah, I'd like to thank the DAF staff and CSIRO for helping with this, and yeah, Andrew Smart. Smarty also wanted to say that in the Moree region, he's going to make available an EM38. Just an old one for people that are interested in getting this sort of up and running, and he's basically going to try and make a calculator for it as well for the different soil types in the Moree region. Thank you.